Hi students, in this video I'll be going through the 2013 O-Level Mathematics Paper 2 question 7B. Alright, so this is a question regarding the properties of circle. Right, so let's read the question. So the diagram shows a circle A, B, C, D, alright, with center O. Okay, so there's a center given. AE and DE are tangents to the circle, and X is the point of intersection of AD and OE. Right, so X is the point of intersection between two straight lines, AD and then OE. Okay, angle AEO is 23 degrees, and angle CAO is given as 26 degrees. Okay, so over here, just for 1 mark question, you're asked to name a pair of congruent triangles. Okay, so if you recall congruent triangles, okay, congruent triangles means they must have the same shape, and then they must also have the same size. Okay. Okay, in other words, the two triangles are identical. Okay, so I think from this question it is quite obvious. Okay, there's more than one answer. Okay, but if I were to choose, I'm going to choose a triangle AOE and DOE. All right, because I can clearly see that there's a lot of things that I can use to prove the congruency already, or to confirm the congruency. Okay, although for this question we are not required to write the proof for congruency. Okay, but I'm going to write it out anyway now. Okay, so that we can recap a bit about the different tests for congruency. Okay, so the two triangles that are similar, congruent, okay, will be for me triangle AOE. Okay, triangle AOE. Okay, triangle AOE congruent to triangle DOE. All right. Okay, so let's think about the test. So if it's, let's say, a 3 mark question, then you have to write the test. Okay, so we might as well just revise through. Okay, for these two triangles, you can clearly see, right, there are some sides that are already equal. Okay, firstly, the one that's most obvious would be OA will be equals to OD, because they are both the radius of the circle. Okay, so that's what we can write down. So OA equals to OD. Okay, they are the radii of circle A, B, C, D. Okay, so what other lengths are the same? Okay, the other one more obvious would be OE. OE is a common side, right? Both the triangles share the side OE, so OE will be a common side. Okay, so OE is a common side. Okay, so over here we have a SS already. So if you recall, the 4 tests of congruency would be SSS, SAS, AAS, and then finally RHS. So if only we can find, we have 2 sides already, so it's either SSS or SAS. So can we find the third side now? Okay, so the third equal side would be AE equals to DE. Okay, and what property are we using? We are using the property of, you see, both these tangents come from this point E, right? Which is outside the circle. Outside the circle will mean that it's an external point. So the property that you will learn will be tangents for external point. Okay, they will be equal in length, right? When they touch the circle. Okay, from that point, external point, to the point whereby they are tangent to the circle. Okay, so the last one that we can write would be AE is equals to DE. Okay, then if you were to write the reason, that would be tangents from external point, right? Okay, so in other words, we are using the SSS test, right? For this, to prove this. Okay, so this will be answer for the first part. AOE is congruent to DOE. All right. Okay, let's move on to the questions that require us to find the angles. Okay, so the first angle that they want us to find is angle AOE. So AOE is this angle over here. Right, so for questions like this, we need to be quick to pick up the clues, okay, or the info given in the question. Okay, over here we have tangents. Okay, so the moment you see questions that have tangent inside, right, you should be thinking about the property of circle that are related to tangent. Okay, of which there are only 2. One is tangents for external point, which we have already mentioned. Okay, the other one would be tangent perpendicular to radius, right? And we also have radius OA. So this means that this angle over here is 90 degrees. Okay, so if we know this angle is 90 degrees, then if we consider triangle AOE, then by angle sum of triangle, we will be able to find angle AOE. Right, so that's the path that we're going to take for this question. Okay, so not too difficult. Okay, so let's write down the answer. So angle OAE is equals to 90 degree. Okay, so this one will be because it's a tangent perpendicular to the radius. Right, so once we have written this down, then we just use angle sum of triangle. Therefore, angle AOE will be equals to 180 minus angle OAE minus angle OEA. Okay, OEA. So over here, I'm writing out the working in full. Okay, so you'll get 180 minus 90 minus 23. Okay, then you will get answer 67. Okay, for circle property question, always write your reasons at the working. Okay, angle sum of triangle. Okay, at the working step, not at the final answer step, because you want to tell people whenever you make a choice, right, in your working, okay, what's the reasoning or what's the property that you are using, all right? Okay, so now we found this one to be 67 already. So any angles that you find, you write inside the question so that you don't have to keep rereading again or going to earlier parts to search for info, right? Okay, let's look at part 2. Okay, so I'm going to fill in the angles that we already know. So we know that this is 90. Okay, and this one will be 67. Right, so let's see what angle they want us to find next. They want us to find ODA. So ODA is just this small angle over here. So how can we find this small angle over here? Okay, do you realize that ODA is a special triangle? Okay, what type of triangle is it? Okay, so if you guess isosceles triangle, then you're right, because whenever you have two radius, OD and OA, right, then you should be quick to pick up that this triangle is going to be isosceles, because the two radius are definitely the same length. So if a triangle has two sides that are same length, then it's isosceles. Okay, okay, so if it's isosceles, it means that angle ODA and angle OAD are the same. So only if I know this one, then I will be able to find the angle that we need, ODA already. So do we know this angle or not? Okay, it looks quite obvious that, okay, you should suspect there is also 67, right? But how can we confirm that it's 67? Okay, so remember in part 1, we have already proven congruency that triangle AOE is congruent to triangle DOE. Okay, so this means that angle AOE will be the same as angle DOE. Okay, so that's what we can write down, right? To confirm that DOE is also 67. So angle DOE, okay, will be equals to angle AOE, which will be 67. Okay, so how can we say that? Because the two triangles are congruent. Okay, from part 1. Right, then after that, we can use isosceles triangle to find angle ODA. So angle ODA equals to 180 minus angle AOD divided by 2. Okay, so this one will be isosceles triangle AOD, right? Okay, so if you sub in the values over here, if you sub in the values, then you will be able to get 23 degrees. Right, so the answer over here will be 23 degrees. Right? Okay, so not too difficult. You just have to rely on the info, okay, and be quick to pick up certain information. So always be quick to look out for perpendicular 90-degree angles. Always be quick to look out for isosceles triangle in the diagram. Okay, so whenever you have center and you have radius, right, then likelihood there will be isosceles triangle that you can find inside the diagram, right? Okay, next part will be to find angle ADC. Okay, so angle ADC would be this whole angle right over here. Okay, so over here I'm going to change color of my pen, and then I'm going to highlight the triangle ADC. Okay, so ADC. Okay, so triangle ADC will be over here. Okay, so now we turn our focus to triangle ADC. Okay, so we want to find angle ADC, right? Okay, so if only we know, okay, this angle, do we already know it? Okay, it's isosceles triangle, right? So we can actually say that this is also 23. So actually we know the whole of angle DAC. So in other words, if only we can find angle ACD, then we will be able to use 180 minus away angle ACD and DAC, then we will be able to get our answer already. Okay, so are we able to find angle ACD easily or not? Okay, if you think about it, angle ACD is an angle at the circumference. And whenever you have a center in the question, you should be thinking about the property angle at center equals to twice angle at circumference. So if angle ACD is the angle at the circumference, where is the angle at the center? Okay, so the angle at the center would be over here, right? So if we continue to draw, okay, see the angle at center is AOD. It's formed from, okay, it's an angle that is formed from extending a line from D and A to O. Okay, then the angle at C is formed by extending a line from the same 2 points A and D. Okay, so this means that these 2 points are angle at the center, twice angle at the circumference. So we are able to find this one. And after we find this one, then we should be able to get the full solution. Right, so let's write the answer. So let's write out the angle at center first. Okay, so angle ACD. Okay, angle ACD is the one that we want to find. Okay, the angle at the circumference equals to half times angle AOD. Okay, so its property is angle at center equals to twice angle at circumference. Okay, so you will get half times 67 plus 67, right? Okay, so 134, so you'll get 67 degrees. So in other words, this one is 67. Okay, the angle over here is 67. Okay, then we can just use angle sum of triangle. Okay, so we're going to write the working over here, this side. So angle ADC will be 180 degrees minus angle ACD minus angle CAD, alright? Okay, so CAD is the whole angle at the bottom. Okay, so it will be 180 minus 67 minus away 26 plus 23. Okay, so this will give us an answer of 64. Okay, so this one is the angle sum of triangle. Right, so not too difficult. Okay, then let's go on to the last one. They want us to find angle ABC. Right, so angle ABC is over here. Okay, so let's join this line. Okay, so angle ABC is angle at the circumference. Okay, and in the previous question, we found angle ADC, right? Okay, so we found this one. Okay, so after I've drawn this, I should be quite clear what property we need to apply. So both ABC and ADC, they are both angles formed from these same 2 points A and C. Okay, and A and C is the chord, right? And all chords will divide a circle into just 2 segments. Okay, so one segment is on this side. Okay, so this is one segment. Okay, so this will be the smaller segment, okay? And then the other side will be the major segment. Okay, so whenever you have two angles that are formed in the opposite segments, right? Okay, from the same 2 points, then we will be able to apply the property angles in opposite segment. Okay, so that's basically what we're going to apply to find ABC. So angle ABC, okay, plus angle ADC, right? will be 180. So the sum of angles in opposite segment will be 180. So angles in opposite segments. Okay, why opposite segment? Because they are on the different sides of the line AC. So you see, ADC is on this side. Okay, ABC is on this side. So whenever you have the arrow pointing opposite direction, right, then it's angles in opposite segment, right? If it's angle in the same segment, then the two arrows will point in the same direction. Okay, so angle ABC will be 180 minus angle ADC. So it's 180 minus 64. So that will give us 116 degrees. Right, so this a question in paper 2, so it's usually slightly longer. But just remember how to analyze the question in a calm manner. So circle property question, we should not be trying to just randomly find all the angles in the diagram. Okay, zoom in on the property, look at the info that you have, and then use the correct properties to help you solve the question in the shortest possible way.